Hello Howard, Hans here. I heard from Don and Tendai that you were a bit maybe upset about that we did not have a 1 meter-ish accuracy of the positioning in the solution we are making for you. And I would like to show you why that is not so with this small video. So, first of all, I would like to state that I have never promised you anything like that in the sense of 1 meter positioning when it comes to Wi-Fi positioning. I'm quite sure that I've shown you this picture in meetings where we say that Wi-Fi can give you something in between 50 to 100 meters accuracy, depending on how close you put the access points. Then there are other technologies out there like LTE, which is worse, and those who are better like ultra wideband that can give you actually better than 1 meter accuracy, but it comes with a cost. So saying that, the solution we have proposed to you and that we have discussed in the context of the what you would like to achieve with this, then we had the idea of that Wi-Fi is the best one for you. And to be totally open and honest, Wi-Fi is the most predominantly used technology in the world for underground mining operations as of today. LTE is coming quite strongly, but as you see in this table, the accuracy is much worse than compared to Wi-Fi. So what people are doing instead then is that they are building another network of Bluetooth low energy beacons and put that in the network. So you have actually two technologies, but more on that topic later. So if you go and look more for Wi-Fi and talk about Wi-Fi positioning in general, some vendors are claiming that they can have something better than 10 meters accuracy when using Wi-Fi. And in theory, this is possible in the context of an office space where you will actually see and hear a lot of different access points. So let's assume that you can hear 5 or 10 access points at the same time. Then also being in an office space, you don't have any big machines running around in that surrounding. So everything is pretty much static. And if you would go and measure the signal strengths, how good you can hear this access point in different rooms, then you would be able to, in theory, to create what we call a fingerprint that then could be used to resolve a more accurate positioning of a person in an office. However, when it comes to tunneling and underground mines, this is simply not doable, as you will maybe at most hear 2 access points simultaneously at the most, and that these radio waves actually don't travel through the rock. They travel through walls in a building, but not through the rock in an underground mine. And anyone trying to pursue this higher accuracy in a mine, they are just bullshitting you, because no mines have ever succeeded in that with the use of Wi-Fi. If you then would like to fingerprint, go and measure the signal strengths in a mine, that would be a job that is impossible to achieve, as it would take too long time, and by the time that had been made, then the situation would have changed. So that is not a feasible way forward. In underground mines and in tunnels, the rule of thumb accuracy is a good rule of thumb idea of that accuracy is to say that the accuracy is the same as the half of the distance between the access points, because then you can actually see if you're closer to one or to the other. And if we look more at this topic, you can say that we at MMI, we have currently 2 algorithms that we use for obtaining the position in a Wi-Fi network. the first and mostly used algorithm is the strongest access point. That is what we by standard are using in mines. That is what we are using in a Kappa, in your Kimberley mine as well. And as I said, accuracy is half the distance between the access points, and this method is the most robust positioning method. And with robust I mean that it gives the same performance every time you use it. We have another algorithm that we have used in some cases, which we can call an access point profiling method. That method uses information that we can obtain from some vendors, that we can get how good they can hear its neighbor access points, and we also use the information about if the tunnel is straight or if it's a curve. So we use that in obtaining a more advanced algorithm, and you could say that the accuracy, we haven't really measured it, but we have seen that the accuracy is in 75% of the cases it's slightly better than the strongest AP method, but in 25% it's actually worse. So it has its ups and downs, and this works with Wi-Fi vendors that support this neighbor list, which vendors like Cisco are doing. NLT currently does not use this, but we didn't see this as a problem, as even if you would use this, you would never come down to a 1 meter accuracy. It would just be a slightly bit more better than the strongest AP. Right? So if we're looking as an example from a mine here, if the upper part represents what you see in the MMI user interface, and the part beneath is try to resemble the example in a real mine. So if you have two access points, A and B, as you see down below, and you have a person standing there, he is a bit closer to the A access point, and when we do positioning here in MMI, we then can detect information from the access point how good this tag that the person has on himself can be heard by this access point. In this example, router A can hear this tag a bit better than the access point B. And as that is the case, then this algorithm suggests that the position of this person is beneath this access point. So in the user interface, that person would then be at this position. If this person then walks away a bit, and the tag is signaling some more, then still this A access point can hear the tag a bit better than B, and the B router or access point can hear the tag a bit less than A. In the user interface, then this access point, this person is still regarded being under this access point. If that person now walks away even further, then suddenly the other access point, number B, then hears this tag better than A, and then we move this person in the MMI system to the next position. So this is basically how the positioning works in MMI of today. If then in a rare case there would be a big machine between this person and this access point like this, then actually that access point B would probably not hear the tag at all, because this big chunk of metal, this truck, would stop most of the radiation from the tag. So suddenly the access point A would be the one that hears this tag best. Even if he doesn't hear it too well, it's still the best reading of that tag, and then consequently that person will be positioned under that access point again. So this is basically how Wi-Fi positioning works in an underground mine using MMI and most other systems. What you can say about all this is that I mean, from the 20 plus mines we have in the world that are using Wi-Fi for positioning, they think that Wi-Fi is good enough for most use cases that they would like to have in their mines. It's about localization of machines, personnel, etc. And if you think about it, if you have a mine that has many kilometers of tunnels, then to know where someone or something is within 50 to 75 meters is in most cases totally okay. Like, where do I have to go to find this bolter? Or where do I have to go to find this person? That can be resolved by that accuracy. You can have other features like ventilation on demand to be able to control ventilation based on presence. And that works totally okay with Wi-Fi accuracy. Emergency support is another kind of use case, to know where people are in the case of an emergency. And this should not be, of course, used for locating people in total black smoke. So then you would need an accuracy of maybe half a meter if you would like to find somebody that lays down in the smoke. But this is instead used for knowing in which smaller area there is one or a bunch of people, to where you should send these rescue guys. You can also use this for analytics, to calculate things like phase utilization, or to calculate time, cycle time analysis, etc. So that works very good. And then there are many more use cases where this 50 to 75 meter is okay. So if you look at this picture of a Boliden mine, this is the whole mine from the side, and this is about 67 kilometers. In this picture I highlighted all the persons and machines, and you can actually see where there are a machine or a person now working. If we zoom in this picture, you would see something like this, that in a work area here, in a workplace, you have Per Borgström driving a loader, and that accuracy, as I said, is maybe up to 75 meters inaccurate. But still, you know that person, Per Borgström, is in that area working back and forth. And you have Christopher Örnberg maybe 100 meters more into the mine before the phase. So you can use this for most purposes, I would say. And if you would like to have 1 meter or anything better, then you must actually add another technology onto this, like ultra-wideband or something else. You can't really then replace Wi-Fi, because Wi-Fi will be the core infrastructure for communication, to send pieces of chunks of data back and forth. Or you could use LTE for that. That's coming now in the future. But for increasing the accuracy, then you need other technology, other proprietary technologies, or things like ultra-wideband. But then you will have to have a double infrastructure for this. What many mines are looking at is actually if they would like to have this higher accuracy in some areas of the mine, they will have a mixed solution where you can have a mix of Wi-Fi and high precision technologies depending on what you want to use it for. And the unique thing with MMI is that we are the only system that can actually integrate different technologies into the one and same solution. So with that, I tried to give you the message from our side that we sincerely have not intendedly tried to mislead you in the ways that we could do 1 meter accuracy, but instead, as I said, and as we have said before, the accuracy is something of the half of the distance between the access points, which usually is in between 50 to 75 meters of accuracy. So by that, Howard, feel free to call me if you have more questions on this topic, or ask Jenny or someone else, Don and Tendai. Thank you very much. Bye bye.